This question was repeated in 2008 and 2010. So the question says a beam of alpha particle projected along positive x-axis experience a magnetic force. A magnetic force, it means that there is no electric force, there is only magnetic force. So in positive y-axis, what is the direction of magnetic field? So positive charge is going in alpha particle. What is alpha particle? Alpha particle is helium nucleus, okay, plus. If you have a helium nucleus, take 2 electrons from this, so this will become your, what will it become? This will become your helium nucleus. So this is my alpha particle, which is positive. Now positive charges are going along the x-axis and it experiences a force due to magnetic field, right? In positive x-axis, in positive y-axis, what is the direction of magnetic field? All are positive, so the force will be along the positive z-axis. The force will be along the along positive z-axis. Okay, very simple. Now let us see mathematically. Okay, this is correct answer. So I am going into the physics also. So the force is also given by, what is force? Q V cross of B, all vector. So this is Lorentz magnetic force. So what is the direction of velocity? It is going in the positive x-axis. Like this you have this, okay. You must have studied unit vectors in x, y and z. This will be counted as I cap, this will be counted as j cap, and this will be counted as k cap, isn't it? So this velocity is along the direction of x-axis. So here v, I will write I cap, okay, and force is acting in positive y, so y positive is plus j, so j cap. So what is remaining here? I have got positive I have got positive j cap. What is remaining? This must be the k cap, and k cap is along the z-axis, that is positive, it is not minus k, so the direction is positive z-axis. This question says that a neutron and a proton are accelerated by the cyclotron. Okay, so these two particles are accelerated by cyclotron. Can both be accelerated with same oscillator frequency? So explain with reason. So there are two particles, one is neutron and other one is my proton, and it is being accelerated in cyclotron, and it says that can both be accelerated with the same oscillator frequency, yes or no? So first of all, let us see the oscillator frequency. So we know that frequency formula is equal to QB divided by 2 pi m. It means that this frequency depends upon the mass. Okay, so let me see what are hydrogen and what are deuterium first. Okay, so because from this we get the proton and neutron. So hydrogen is atomic number 1 and atomic mass 1. If you take 1 electron, then this will become proton. You have this hydrogen, okay, this is 1 proton inside, 1 electron here. If you take out 1 electron, it will become proton. Okay, it will become proton. So similarly here, this is my atomic number 1, mass number 1 with positive charge. What is deuterium? Deuterium is an isotope of hydrogen in which you have 1 proton and 1 neutron in the nucleus and 1 electron outside. So if you take out 1 electron, it will become hydrogen plus atomic number 1, but the mass number is 2 because of inside there is 1 proton and 1 neutron. So this is my deuteron. Deuteron has got H1 2 plus. Okay, So which one is heavy then? Let its mass is mass of proton and its mass is mass of deuteron. It means that the mass number is 2 and mass number is 1 for proton. That is, mass of deuteron is greater than mass of neutron. Therefore, we cannot accelerate deuteron and proton by cyclotron with the same oscillator frequency, because mass of deuteron is larger than the mass of the neutron. In fact, it is twice, okay? Twice of the hydrogen, proton. So what is proton? It is nucleus of hydrogen. And what is deuteron? It is nucleus of what? Deuterium. So this is isotopes. Now explain with region. Okay, explain with region. Let me find the frequency of proton first. So frequency of proton is equal to Qb by 2 pi. M is the formula, and how much is the charge? Here also plus, here is a plus, charge is same. Okay, magnetic field for the same cyclotron will also be same. 2 pi is a constant and M is the mass. So charge is same, let the charge be E. Okay, so E and mass of proton. So this is equation number 1. And frequency of deuteron will be how much? E, because charge same, divided by 2 pi mass of deuteron, equation number 2. So let me divide equation 1 by equation 2. I will get F of P divided by F of D is equal to how much? This is EB divided by 2 pi mass of proton, EB divided by 2 pi mass of deuteron. So EB cancels, 2 pi cancels. So what do I get? I will get frequency of proton divided by frequency of deuteron equals to mass of deuteron divided by mass of proton, because this will go in numerator. So which is mass of deuteron is 2 and mass of proton is 1. From this, mass of proton 1, mass of deuteron 2. So what do I get here? I get from this, what do I get here is, I get mass of proton is equal to 2, frequency of proton is equal to 2 frequency of deuteron, because the frequency of proton is as twice as the frequency of deuteron. So these are not same. It means that we cannot oscillate with the same oscillator frequency. Question is that a proton moving in a straight line enters into the strong magnetic field along the field direction. A proton is moving in a straight line, enters into a strong magnetic field along the field direction. So how will its path and velocity change? 2011. So the velocity and the path will not change. Okay, so because the angle between the magnetic field and the velocity and the direction of the charged particle is same. For an example, if this is my magnetic field, okay, very strong magnetic field in x direction, okay, in x direction, say like this, x, y and z. Now a charged particle, proton, okay, it is positive charge, is moving here and it enters into the strong magnetic field. Then how will its path and velocity change? Okay, first of all, what we need to do is, it will experience a force. Whether experience of force or not, it is given by Lorentz magnetic force. So the force, Lorentz magnetic force, is equal to Q V B sine theta. So it is going with the velocity v. What is the angle between this v and b? B and v. The 9, it is 0 degree. So sine 0, this will be Q V B sine 0, which is equal to 0. It means that the trajectory of the path will not change, as well as the velocity will also not change, because the force is 0. Very simple question. The trajectory, the path will not change, and velocity will also not change, because the angle between B and V here is how much? 0 degree. Okay. Question says that write the expression in vector form for the Lorentz magnetic force. Please remember, for the Lorentz magnetic force due to a charge moving with velocity v in the magnetic field. What is the direction of magnetic force? So what is the equation of Lorentz magnetic force? So we have Lorentz force is equal to, always in vector form given, QE vector plus Q V vector cross of B vector, both in electric and magnetic field. But the question says only in the magnetic force, it is magnetic force, so we don't need to write EQ because E is not there. So this is my what? Force, magnetic force experienced by the charged particle with the velocity v, and this is the velocity v, and this is the force. This is magnetic field B, and Q we have considered as the charge. Now next is, what is the direction of magnetic force? So to give the direction of force, we use what? We use Fleming's left hand rule. Okay, Fleming's left hand rule. Father, mother, child. Mother, direction of magnetic field. Child, the current or the charged particle. What is the angle of three fingers? 90 degree. Okay, so what I say is, what is the direction of magnetic force? The direction of magnetic force is perpendicular to the both magnetic field and the velocity. Okay, the direction, this is also perpendicular to the magnetic field and also perpendicular to the velocity. So the direction of magnetic force is perpendicular to V and B both. So this is the answer. It was asked in 2014. This question was asked in 2013. It is very simple questions. We say draw the magnetic field lines due to current carrying loop or a current carrying circular loop. So this is how it look like. So for this, what I have considered is a circular coil like this. Okay, so this is the circular coil perpendicular to this one. Okay, simply you just remember this diagram, it will be all okay. But I am also giving some idea how these arrows has come here and how these arrows has come there. So this is like this. Okay, please understood, this is standing like this, not like this, it is like this. So here the direction of current is in this direction, it is rotating like this, making a clockwise direction. Okay, the direction of current I is clockwise direction. So first of all, let me go to this end. What is the direction of current at this end? Is going inside, because it is just like this. So this is my circular coil and the current is revolving like this. What is the direction of current over here? It is going inside. So the current carrying conductor have got magnetic field. The direction of magnetic field is given by right hand thumb rule. So I have to hold it in such a way that this thumb represents the direction of current and this curling forefinger will give me the direction of magnetic field. So it is just like this. So the direction of current is going this side at this point. So I have to hold it like this with the thumb pointing towards the direction of current. So whenever I hold it, it is making a round circle in this form. So the magnetic field is in this form. So here it is going downward, and here it is coming upward, so coming upward. Similarly here it is a round circle, the current is coming in this direction. So I have to hold it like this, giving the direction of current by this thumb, hold it. So here the direction of magnetic field is going inside, and from here it is coming outside like this. So this is all about the magnetic field. Now what will happen here is, it will make a big circle like this, big circle going inside, passing through this ring. So all this magnetic field is going downward. Okay, of course it will make a circle like this, so you can even have something like this here also. It is going like this and making a big circle and coming into it. Again going inside, making a big circle. Going inside, making a big circle. It is very simple diagram. So this is the application of Biot-Savart law, which says a circular coil of closely wound antrons and radius r carries current I. Write the expression for the following. Number 1, the magnetic field at its center. Number 2, the magnetic moment of this coil. Okay, magnetic moment, it is a very important quantity. So first of all, let me go to the thing that we have derived. So we have done like this. Okay, we have taken the radius r as a, distance from center to the point P as x, and this dl to the point P, we have taken this as r. For that, what we have got is, we have got the magnetic field B is equal to mu naught I a divided a square divided by 2 a square plus x square to the power 3 by 2, that we have got. Okay, but in question what it is saying is the radius is not a, it is x. Okay, we have to do it with this. So in my derivation I have taken this as some other factor. So this I will call this as, say, capital R. Okay, so for this now, for this question, our equation will be changed. The magnetic field at this point P is V is equal to how much? Mu 0 I, A is radius, so here radius is R square divided by 2 and A square plus x square to the power 3 by 2 at the point P. According to this one, you have to derive this also to solve this question. Okay, so how to do? The question says at the center. At the center means you have to bring this point P here. If you get it here, this x will reduce, bring it here, x will reduce, bring it here, x will reduce. Whenever you come here, x will become 0. At this point, x is equal to 0 because the x is distance from the center. You go on 1, 2, 3, 4, 5, 6, increasing, reduce, 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 reduce. You will come to the 0. So you will get how much? Then you will get mu naught I r square divided by 2 is there. Then it will be a square whole to the power 3 by 2 is there, and this 2 and this 2 cancels. Not a, this is, sorry, r is again the radius, this is also r, so it will give me mu naught I r square divided by 2 r cube. So this will cancel and this will be my answer. But again, what is it saying is there are how many turns and number of turns. Whenever we derive this, we did not take n number of turns, we only take only one turn. So if I take so many turns, the magnetic field will be how much? I have to multiply here with capital N, here with capital N, here with capital N. So finally, the magnetic field at center, I will get N mu 0 divided by mu 0 I divided by 2r. So this is the answer for 1. So answer for 2 is magnetic moment. Okay, magnetic moment. How to define the magnetic moment of coil is equal to magnetic moment denoted by capital M is equal to Ni into area of coil. So this is the magnetic moment. Therefore, N is the number of turn, I is the current. What is the area of coil? The area of coil is pi r square. So this is my magnetic moment, or simply you can also write N I A is the magnetic moment of this coil. Okay, so in derivation I have taken this as A, but you have to solve it according to the question. Okay, so let us go to the next question. Some more questions are like this. Using Biot-Savart law, find the magnetic field at the axis of a circular coil of radius r 2016. So this answer will be how much? This magnetic field is equal to mu naught I a divided by 2 a square plus x square 3 by 2. A is the radius. If it is okay, then if r is there, so I have to write this as capital R. This is also capital R. Okay. The same thing. Obtain the expression for cyclotron frequency. Its answer will be F is equals to QB divided by 2 pi m. Please see the derivation. It was asked in 2017. This is all the derivatives. State the Biot-Savart law in vector form. State the Biot-Savart law in vector form. So dB vector is equals to mu naught by 4 pi I dl vector cos of r vector divided by r cube. So we have already done this. Please go to the video if you are not understanding. A long solenoid of length L having n turns carrying a current I. Deduce the expression for magnetic field in the interior of the solenoid. In the interior of the solenoid, which you have done, the magnetic field, it will be mu naught n I. Mu naught n I. Okay, mu naught n IA, Ampere Circuital law. So state Ampere Circuital law. It is very simple. Please go to the video. It was asked in 2010. And deduce the expression for the magnetic field inside toroid. Inside toroid carrying current I and having the turns n. N turns 2011. Its answer will also be equals to mu naught n I. Same, okay, for magnetic field due to toroid and magnetic field due to solenoid are same. So these are the some board questions. Okay, if you have any problem in some other question, then you can always ask me. Okay, so if it is better if you all solve this in your copies and all, and especially for my students, you have to solve this. Okay, at your home in this lockdown. This is very nice. समझ रहे हो ना? करना है सब, ठीक है? जब स्कूल में आओगे दिखाना भी है, समझे?